Yes, hello and welcome back to the FIWARE Smart Fest. It's all about data spaces. Thank you for joining also the open and moderated tables in the lunch break. For everyone not joining in, I hope you had a nice lunch break, enjoyed the meals, and yeah, I'm really happy to announce that we can go on now with the next session, which will be about smart data models and data spaces. And for that, I have my colleague from FIWARE here, Alberto Abella, who is our Mr. Smart Data Models. He's a data modeling expert. And yeah, I will give it over to you now, Alberto. I hope you all have a great afternoon here at the FIWARE Smart Fest and enjoy all the new content.
Okay, thank you very much. I'm just sharing my screen. Hopefully you're all seeing. Yes, hope so. So thank you very much and welcome to this session for the data interchange with the smart data models and data spaces. So let me introduce the session. After me, giving the last update about the Smart Data Models program will be Bruno Johnson from the Open Connectivity Foundation, talking about the new relation between FIWARE and Open Connectivity Foundation for the mutual adoption of data models. After that, Mr. Rakshit Ramesh will talk about the IUDX and the smart data models and how are they using and contributing. And thank you, IUDX, for the current contribution. And the last one, but not the least, will be Manfredi Pistone talking about OPCOA, an IoT standard, and how smart data models are helping to boost the industry further though. Okay, you can make questions on the chat, and hopefully our marketing team will help us to answer while the session. So what will be my speech about? It will be just the Smart Data Models program. I will define it. And this is the agenda. I'll introduce explaining what's the current status and what are the differential factors of this program compared with other standardization activities and why these differential factors are critical for their use into the data spaces. After that, we'll talk a bit about this data interchange in data spaces thanks to the smart data models and a bit about the future of the initiative, what is going on to happen this year, some of the things that is going to happen. So first of all, what are we talking about? We talk about an initiative which is led by IUDX, the Indian Urban Data Exchange, part of the Ministry of Home Affairs of India, and controlling the technology deployment across smart cities and now beyond that. Open and Agile Smart Cities, which is a worldwide association of cities with more than 150 cities across Europe and Asia, and TM Forum, which is possibly the larger telco operators association across the world. What do we do in the Smart Data Models program? First of all, it's a collaborative initiative saying that everybody is entitled to collaborate, to provide multi-sector data models. So we are covering all the sectors of activity. These data models are free, so there is no cost on using them, and they're open license, which entitles you to use it as much as you want, to modify, to customize your needs, and to share these modifications. And possibly the most important, and that's why it's underlined, because they are based on actual use cases and adopted open standards. So we are not here for designing something and to test into the market, but the other way around. So we provide a standardization for those things which are already working. What is not the Smart Data Models program? It's not another ontology. So we are not here for creating things. If we have to standardize something, it's because there is no formal standardization. It is not something which only works with NGSI standard and FIWARE platform. Of course, it works with it, but it can provide usefulness for many other solutions. And we are not a standardization body, but an agile standardization program, and we will see the differences in the differential factors section of this speech. What do we provide? We provide a specification. So we have the definition of the terms to be used in every data model in 6 languages: English, French, German, Spanish, Japanese, and Italian. They are automatically generated, and we are proud of it, but for the English one. We provide also a technical validation. So we create a JSON schema, which is the single source of truth, because this technical schema allows you to validate the payloads if they are compliant with this model, and includes the definition. So once you modify the JSON schema, then everything is generated after it. And that's why everything is automated, and that's why we can accomplish of the requirements is to be agile. And last but not least, we provide also examples of these payloads from the real use cases. Okay, and we create exports in several formats, and we will increase this during this year in JSON, JSON-LD, GeoJSON Futures, DTDL, which is a digital standard from Microsoft, CSV, and so on. So what's the current status of this? We have right now officially published 717 official data models, and there is another 88 on the queue, so we can round up approximately 800 data models. These data models are grouped in 53 subjects, and these 53 subjects belongs to 12 domains, which are like industrial sectors, like smart cities, smart water, smart environment, and so on. Currently, there are 111 contributors, and these contributors belong to 71 different organizations. So when at the very beginning we say that there was 4 organizations leading the initiative, it is true, but it's also that there are another 71 pushing for the initiative. Currently, there is around more than 15,000 terms defined in these data models. And as I've mentioned before, we are not here for creating things, and these data models has a service in which you can map it with existing ontologies and vocabularies. We have currently 18 of this, and if you wish anything else, please let us know, and we will create the 19 for you. Some of the standards which are already mapped here are OPCOA for IoT devices, of course, OCF specification that I expect Bruno will comment in the next session, GTFS and GBFS for mobility, Common Information Model for energy, DCATP for open data, IPANET for the water sector, and Open 311 for civil protection. Okay, some examples of the last data models, and I promise that they are the last ones. So there are data models for the definition of the accountability of the Digital Innovation Hub, for unmanned aerial vehicles, what is the formal name for drones. There are 7 of them. For open connectivity, so these data models coming from our relation that we will be explaining into the next session. Another very different one, which is the proof of vaccination, according to the European standard, currently massively used for COVID, but it can be for any other illness, or for the definition and accounting of a wastewater plant, or for the feeder of a streetlight. So as you can see, there are very, very different things here coming on. What are the differential factors of this program? Because everything is open license. So you are free to use, free to modify, and free to share such modifications. It's collaborative, so this is not a group of experts, but it's a group of users, which is slightly different. We are not reinventing the wheel, so whenever there is an open standard and it's adopted by the market, we map it. Everything is automated to the maximum extent, so the publication and translation system is automatic, and therefore once we modify the single source of truth, we run the programs and everything is published. So with this automation, we are capable of publishing something in days, compared with some classical standardization body, which takes, let's say, 1 year or 18 months and these kind of things. And we are mapping existing vocabulary, so we are not here for inventing things. So regarding the data spaces, possibly many of you are familiar with the data spaces, but maybe some of you are not that much. So let me define the data spaces like these spaces in which we will interchange data between providers of this data and consumers of this data. And we have to guarantee these 12 blocks. First, that we agree on what we are interchanging, and this is possibly why the smart data models is here, because we have to agree that this data means the same for you, for me as a provider, like for you as a consumer. If we don't have this, then we can purchase this data, but then we have a problem. And the Smart Data Models program is relevant here because we are capable of defining new data models, let's say, in project's time. So we don't have to wait 1 year for having a new data model or for modifying an existing data model. Okay. Of course, we need an API for interchanging the data. NGSI LD is possibly one of the best options. We have to guarantee the traceability. So these data are coming from me and it's going to you, and we can demonstrate that. Of course, we have to demonstrate that me is me, okay, some way, and that you, which are the receiver, are you, and of course, and this exchange is trusted, so nothing happens in between. And of course, this exchange has to implement some access and usage control policy. So you can use this data this way, or that much, or with this period of frequency of update. Of course, you have to find what is available, and therefore the data space needs to have some metadata and discovery services. And of course, this data has to be available into a marketplace and be able to publicate and to generate a federation of these publications. And finally, last but not least, you have to take account of what are the transactions, independent if there is a billing between the users, because open data can also have their place here into the data spaces. You need to account it for it. And of course, this is the technical part, but there's also a governance part in which we have to sign business agreements to implement very different billing policies and to agree if a new group of users are trusted, there has to be an agreement and these kind of things. So with this, the relevant factors for the data interchange are these 8, according to some scientific publications, which is the licensing, can be Creative Commons, or could be some others, or could be these factors related with the access mechanism on the technical formats, which are covered by the standard NGSLD, or those dimensions related. If we understand the same thing for the information, we share the geolocation and we share the frequency of update, which is covered by the Smart Data Models program. And something which is not covered, but it's emerging, is that the prestige. So if you are trusting of the reliability of the data based on the prestige of the publisher, and of course, to have the means for the communication. So these data spaces has to provide you with means of say, oh, you are publishing this, many people will be understanding what are you publishing. And last but not least, and we have 2 minutes for explaining this, what is the future? The future is keeping growing based on the collaboration with the users. And one of the goals for this year is the integration with data spaces so that you can validate if some data are compliant with a data model specified or not. We have, let's say, the schemas for doing that, but we don't have a service, a specific service. So this validation has to be, or maybe a service that you can consume, or releasing as an open source the software for doing that validation. Another line of work will be the mapping of the open regulations, specifically for sustainable development goals and circular economy, also for the integration with OpenStreetMaps and other geographical resources, the mapping with robotics, or always based on the demand of the users. And last but not least, apart from these sectors which are already widely implemented, like sensoring, smart cities, energy, other emerging sectors like agri-food, health, manufacturing, and robotics will be into our priorities for this year. So hopefully I'm not seeing the questions. If not, thank you very much for listening, and I pass you the floor to my colleague Bruno Johnson for his speech. Thank you very much. Bruno, I'm stopping to share now. You can.
Okay, thank you, Alberto. Can you just please confirm that you can see my screen?
Yeah, see, and loud and clear.
Perfect. Thank you very much. So, yes, my name is Bruno Johnson. I am chair of the Marketing and Communications Work Group of the Open Connectivity Foundation and also CEO of IoT communications company Cascoda. And today I'm very, very pleased and proud to be able to present to you the beginnings of what I hope will be a very strong and fruitful relationship between FIWARE and the Open Connectivity Foundation. And what I'll talk to you about today is a little bit of an introduction to OCF and the mutual adoption of each other's data models. So I'll talk a little bit about OCF, the connectivity methods that OCF enables, a little bit about the secure IP device framework that underpins OCF, our data models and the code generation that goes along with that, what we think are the benefits of collaboration for both organizations, and then some links regarding the specification and our contact details. So what is OCF? We have something we call three-pillar alignment. This means that we have an open ISO IEC standard protocol for IoT. And we believe the ISO IEC standardization is very important for adoption at the national level as a national country standard. As well as that, we have an open source implementation that is confirmed to match that standard. And that allows users to easily and quickly build solutions based on the standard. And then lastly, we have a certification testing program that ensures interoperability of devices that are based on the standard. And those three things go together. So whenever we do a new release of the standard, you can guarantee that it's backed by ISO IEC. There is the open source implementation will work with the conformance testing tooling, and you can guarantee that there will be interoperability. So what IoT device connectivity methods does OCF enable? Well, first of all, we enable device-to-device communications. Now, this is across any combination of internet protocol connectivity spaces. So it doesn't matter what your combination of physical layers are, provided that this is a true standard IP-based, internet protocol-based communication, then you are able to use the Open Connectivity Foundation standard on top of that. But we also have bridges to non-OCF communication standards. So this is quite important because, of course, we know that there are an awful lot of devices that are built with protocols such as Bluetooth or Zigbee, and we are able to communicate with those devices, but still with a very strong, secure interface into the secure Open Connectivity Foundation connectivity domain. We also have device to cloud communication that allows for secure communication between a device and a cloud, or between a device through a cloud to a device on the other side of the cloud. And uniquely, we also have cloud to cloud communication. So it is possible to securely share data between two different cloud environments. And because all of this is backed with certificates, which also have roles associated with them, we can have a lot of control about what is shared. So what is the Open Connectivity Foundation Secure IP Device Framework? Well, this is really the connectivity infrastructure that enables the secure IP communication. As mentioned before, this is vertical agnostic. So you can really apply it anywhere where secure IP communication is required. And as mentioned before, it's backed by the open source implementation. And uniquely, it is compliant with most of the known IoT security baseline standards that are coming out from government. And we have benchmarked this against these standards, both that are coming out of the European Union, the United States, and the UK. So what does it contain? Well, first of all, device discovery. You can use OCF to discover other OCF devices within your network. And then once you've discovered them, you can perform resource discovery. So you can find out, for example, what resources a light may have, whether it has dimming functions, RGB functions, and so on. And then extremely strong security based on transport layer security and certificates. So this allows for secure onboarding of a device. You can take control of that device, and all the data that is transmitted across the network is encrypted. And these certificates allow for access control lists, granular control of what you can or cannot do with that device, depending on what sort of access you have been granted. Okay. So just to look at the technology, I won't dwell on this too much, but OCF is based on a basket of IETF specifications, which are all well-known international standards. And on top of that, we have the Open API v2, and you can build your own data models on top. As mentioned, it is secure by design. We have done an awful lot of work to benchmark OCF's secure IP device framework against all the emerging baseline IoT security standards. And all of this is available online. So if you click on the link shown below, you are able to see that we have compared every clause within each standard against the relevant paragraph within the OCF specification and made notes. This is a very, very comprehensive piece of work, and that extends to, I believe, about 18 pages of work. So, and recently, we have a fantastic use case of this technology. The Korea Land and Housing Corporation, which is the part of government responsible for all social housing, has adopted the Open Connectivity Foundation standard, and it is being rolled out across 223,000 households by 2025. It's based on a secure IoT smart hub in each home. We know that there is one stand has been certified by Korea Telecom. I believe others are being certified right now. And this has mandatory fine dust particulate type and CO2 sensors are built into it. And this data is securely transmitted back to local authorities. So this allows local authority decision makers to make better decisions regarding planning, traffic, and so on. It is able to control 15 types of devices. We'll look at the types of devices later via an OCF compliant smart home app. And this is very much about leveling up access to healthcare to improve healthcare outcomes for people who may be less mobile, intelligent safety systems, a greater convenience, and improved energy management and control. There's a link to the press release there. So a little bit about data modeling and the associated code generation. As mentioned before, we use the Open API v2. I believe FIWARE uses v3, so I think there is a lot of compatibility. So the payloads are defined in JSON and described by means of a JSON schema. The Open Connectivity Secure IP Device Framework defines security resources and core resources, and everything is available on the internet, and I've provided some of the links. At the moment, we have 85 device types, so the link is there, and I've shown you the way the page works. It's done in alphabetical order, so we've got 3D printer at the top. But devices are things such as air conditioners, speakers, printers, and so on. And these are mostly in the smart home and smart building space. And I believe 180 resources. So for instance, for an air conditioner, we may have air quality resources associated with that. Other devices may have, let's say, battery resources associated with that. So the full list is shown, and this is all open. Anyone can access it. As well as that, we have automatic code generation via a device builder application. Now, this is very nice for people who are actually making things, because it takes away a lot of the, if you like, grunt work in pulling out the relevant data models and associated resources. So we have an input file linked to the data models which are on GitHub, and then you can automatically generate your code associated with the data models that are required for your specific device. And this is a tool that is part of what we support, and it is multi-platform. So I wish I could go into a bit more detail of this, but the time limits us. So what we believe are the benefits of collaboration for the two organizations. I'm sure there are plenty more benefits than are shown here, but really, I think for FIWARE, we have a comprehensive set of smart home and building models that can be adopted. But also with OCF adopting FIWARE's models, in time, FIWARE's models will be brought into the ISO IEC standard of OCF. So I think this brings a tremendous benefit. And also ability for FIWARE members to use the OCF's ISO IEC Secure IP Device Framework to create products. Now for OCF, of course, this is fantastic for us because it gives us access to a set of smart city models and in industrial models. And it provides new potential adopters for the OCF standard. And Alberto tells me that there's potential integration of FIWARE platform to OCF smart home and smart building models as well. So just to provide a few links. So the specification that OCF creates have been adopted by ISO IEC, and I've given the link to the first one. There are, the way ISO IEC works, there are lots of documents here, so this is just the first of about 18. The specifications, the most up-to-date specifications, are always available at this link, and there is a presentation that is maintained that goes alongside the presentation. I've put a link to the latest one there. And this is the general contact for the Open Connectivity Foundation. If you send an email there, it can be forwarded on to the appropriate member. So yes, that's it from me. I think I'm a little bit below time, so Alberto, I was assured that I wouldn't take up too much time for you, Alberto. So
that's fantastic. 1 minute ahead, so it's
okay.
Not any problem at all. So thank you very much, and possibly be aware of the chat because some question could appear there. And
okay.
Thank you very much. And without other change, I pass the floor to Rakshit, who is going to talk about IUDX and smart data models. Rakshit, are you ready?
Hi. Am I audible?
Yes. Please share your screen. Yes, we're seeing now the same session and now presentation mode.
All right.
Okay, great.
Okay. So IUDX and FIWARE have been partners since at least the last 2-3 years. And since our inception, we've sort of closely worked with FIWARE on both the NGS LD APIs and data modeling. This talk, I'm going to basically present you what IUDX essentially is and our collaborations with FIWARE and smart data models and our road ahead in collaboration. So what is IUDX? IUDX is a platform for data sharing. We call ourselves a data exchange with the Indian Urban Data Exchange. And essentially what it is it's a layer between non-personal data providers and the data users. And what we provide is a seamless way of accessing this data and also understanding it through the means of common data models, standards, and APIs. Uh, Essentially, IDX boils down to three components: the catalog server, where consumers of the data discover data sources; resource server, where the data actually resides. This could be in any city server, or it could be hosted in the cloud. There are numerous resource servers that can be made available to access different sources of data, and a consent server to actually request consent for accessing said data. Now, the crux of my talk deals with things in the catalog server. Essentially, we're trying to model the data sources information here, and we're allowing users to infer and understand, what property means, how to understand data, how to interpret it, and how to relate it with similar data sources from non-IODX providers. And IODX as a product is fully open source, and we are aligned with HC and JSLD APIs for data access, and also smart data models for data interoperability. We partner with FIWARE actively and smart data models, and our collaboration extends to the government, industry, academia, and citizens. And we have a dedicated team for city engagement and evaluation of IODX readiness, catalyze with startups to enable them to consume this data and make applications out of these as well. Um, and this is essentially what we're trying to do. We're trying to combine public data and privately owned data and provide a common mode of access for the same. Um, we not only confine ourselves to the smart city data space, but also, you know, we are also into mobility, healthcare, agriculture, industrial domains. So what this means is that we have a large corpus of data sources and terminologies that are both commonly used between these domains and also used widely globally to make applications interoperable. Um, so coming to the talk, uh, IODX vocabulary is essentially a JSON-LD based RDFS schema, and we leverage the concepts of linked data to ensure interoperability of schemas and semantics and ontologies. We also have our own ontology to make some of our internal operations, API consumptions, and discovery easy. And also we also operate on the data modeling space, where we actively work with cities and engage with them and sort of model their data to make it compliant with the semantics that we standardize. So our models are strongly grounded with RDFS terminologies. This helps us, in extensively representing our knowledge, and also enables applications to reason and infer. For example, finding similarities of properties between data sources from different providers and so on. Our data models are also easy to define, develop, and extend and integrate into data sources and catalogs to make smarter applications. Some of the ground issues that we see from our deployments, and to talk about it, we are currently in 20 cities across India, and we've seen at least 30 or 40 different domains. And these are some of the common problems that we see across in different cities. Uh, the first one is the same concept but different representations. So a lot of different providers could call carbon dioxide through different terminologies in their data. They could say CO2, carbon dioxide, etc., etc. And there's a need to sort of standardize and harmonize these different terminologies with a common semantic binding, so that applications understand that it's the same gas that's measured between these different data sources. And therefore, it is often difficult for providers to do this. What we offer is a sort of a plug-in approach to unify these concepts into the same entity, which is carbon dioxide. And then you also have inconsistent data formats. Uh, carbon dioxide is essentially a number, but it could be represented as a string in the data. And it's important for providers to somehow be able to specify to the data exchange that, this is a number, but its representation may be in a different format. And, after such a definition has been made, uh, it is incumbent on the tools that we provide to sort of make access to the same data seamless and interoperable, and without much ambiguity in what value that property is representing. And also what we see is a lot of missing information about metadata. And what we try to do is provide a means to represent the same in JSON ID. So another thing we're trying to do here is sort of link concepts across different ontologies and definitions. And in the case of smart data, what we do is sort of make a JSON-LD context mapping to the terminologies in our vocabulary to the terminologies in smart data. So for example, air quality index might be a terminology in provider's data source, but we sort of map it to smart data air quality in through JSON-LD bindings. And therefore, an application which consumes this data can easily understand that AQI, which is coming in a data packet, is the same as what smart data implies by air quality index. This is sort of a messy diagram explaining, how we build our ontologies and make it RDFS compliant, so that applications can start inferring and reasoning based on this. Our data types are fundamental data types, and a little bit more complex properties build over this. So, for example, name and description, and in this case, coordinates. And then certain more complex structured data types can use such properties to form a more contextual property belonging to a certain domain. So, for example, location can just say that it is of type GeoJSON, and it can be used by a data model, which is transit management. And this is the sort of the instantiation layer where I'm trying to show you how an entity can describe itself. So this particular entity, my bus one, is essentially saying that it is of belonging to the transit management data model, and it is also of type resource, which is an IODX internal representation of a sensor. And as I mentioned before, a consumer comes to the catalog to discover this resource, but the data actually resides in the resource server. So the resource server can also link itself to the same concept and have a property coming dynamically in the data stream, represented by this sort of a relationship. And basically, this is how data models help us to sort of lay out our data between our catalog server and the resource server, and make these concepts sort of available to applications to sort of infer the types of the properties that are coming in the data. So coming to our relationship with FIWARE, what our relationship is based on essentially strong alignment on core principles of open data exchange via standardized interfaces and APIs. As I mentioned, we are NGSILD compliant, and also our data models are sort of unified. We actively collaborate in porting data models from IODX to smart data models in the smart city landscape, and this is all in an effort to create a global app development community, so that applications are easily portable and interoperable. We use existing data model properties from smart data models whenever applicable, and we use linked data attributes to also signify these these properties that we're borrowing from smart data models, so that an application which is running on IODX can also run on FIWARE. And what are the typical data sets available with IoTX? So far in our deployments, we have seen sensor-related data sources, air quality, flooding, weather, street lights. We have seen vehicle tracking, which is basically bus tracking, ambulance tracking, and so on. We have seen solid waste management, so the level of bins, the weighing station data, bin locations, and vehicle tracking. We have seen point of interest, which is essentially GIS kind of data, and also an important thing is video files from live camera streams. What we have done is we have modeled all of these diverse data sources and also ported them onto smart data models, so that us being in the frontier of smart city data exchange in India, uh, we contribute back to smart data models and also borrow concepts from there, so that these data sources are also globally recognized, and applications can build upon these common terminologies. Some of the data models that FIWARE has adopted from IoTX data models and we managed to port into FIWARE are as listed here. And we are also working on a few more data models. And some of the interesting areas are agriculture, where we want to model land use, metrology, and land surveys. We want to, and another thing of interest is governance, which is something new uh, even for smart data, where we want to sort of model property holder aggregates, trade licenses, surveys, and censuses. We're also trying to model data from non-structured data, for example, satellite imaging, and so on. Some of the use cases that we have enabled through the data models that we've developed with smart data models are shown in this table here. Most of the bulk of the data sources that we see are transport related. So we actively use the GTFS specifications that are commonly developed, between IODX and smart data as well. And both of us use the same GTFS terminology. So we don't just create new data models, but we also sort of reuse concepts from other ontologies as well. So there's a lot of benefit from the kind of standardization what we're doing. City administrators have reduced development cost and faster deployment solutions. Citizens can develop innovative and cheaper applications for services and conveniences, leveraging NGS and APIs and the data models. Data providers have possibility to share these raw data as well as insights derived, because our concepts not only extend are not only limited to raw data but also aggregated and analyzed data. And industries and startup again have lower cost and higher speed of development. And academia and research have more meaningful research and development with access to wide variety of data. Again, I think almost out of time, but these are some of the applications that are enabled because concepts are shared across different data sources and are also linked to each other. So, for example, a multimodal transport application uh, would require data sources from city buses, metro rails, taxis, e-bikes, and shared cars. And our data models enable such an application to easily discover
Last minute.
these data sources, and also understand the concepts of the data flowing from them, uh, and understand units, descriptions, ranges, and so on from the terminologies defined in our data models. And I think, to summarize, our collaboration with smart data models is to achieve full interoperability, improve data usability, aid application reuse across different cities, and develop linked data tools. And we strive to continue to add more data models to the repository, and also venture into new data domain verticals such as agriculture and logistics. Some of our future works include developing tools to automate conversion between smart data models and IoDX vocabularies, developing RDF graph-based APIs for inferences and reasoning, and venturing into new data spaces and modeling complex structured data. These are some of the links for the resources that I mentioned, and we also have a website where you can discover the data models that we're using, the terminologies, and so on. And the same is available as a GitHub repo where you could also contribute. Yeah, so that's it. Thank you, Alberto.
Okay. Thank you, Rakshit. You have been straight to the point. So now directly, Manfredi, the floor is yours for explaining OPCOA and the boost for Industry 4.0.
Hello, good afternoon. Let me share my screen.
Yes.
Okay, can you see it?
Yes.
Okay,
great.
perfect. So good afternoon to all. My name is Manfredi Pistone. I'm a researcher and member of the Digital Industry and the Agri-Food Unit at Engineering Informatica. And today I'm pleased to lead the discussion about how smart data models are boosting the Industry 4.0 and also the importance of harboring the OPCOA companions and the best sellers machines under the smart data models. Before doing that, I just want to briefly introduce the Industry and Security Technologies Research Innovation Lab, to which my unit is part. So in a nutshell, we can say that our mission is to conceive, design, develop, and demonstrate innovative solutions and concepts in various sectors, like industry, agri-food, transport, security, and defense. And we've got more than 50 running projects at the moment of speaking. Regarding my unit, our main research topics and interests span from the IoT technologies to the edge computing, the big data analytics, decision support systems, and so on. And we spend a particular effort in fostering the adoption of open source technologies based on FIWARE in the manufacturing domain. As you know, nowadays smart factories rely on the building blocks of Industry 4.0 to enable real-time communication between sensors and machines, and this is done to enable features like real-time monitoring, quality control, predictive and prescriptive maintenance, and so on. And within this context, engineering has matured several experiences and has built several complex systems that rely on interoperability, open standards, modularity, and connectivity, leveraging the FIWARE technologies as backbone of these complex systems. In particular, in one of these experiences, engineering focused on the integration of an UPCOA device into a publish-subscribe system based on FIWARE, namely the Orion Context Broker. Thus, we gave birth to one of our most successful products, which today represents also an official FIWARE asset, the OPCOA IoT agent. However, let's start from the beginning, so let me explain you what OPCOA is. So OPCOA stands for the Open Platform Communication Unified Architecture, and is a platform-independent service-oriented architecture released in 2008 that integrates all the functionalities of the classic OPC specification. In particular, OPC is the interoperability standard for the secure and reliable exchange of data in the industrial automation space. So to summarize, we can say that OPCOA is a protocol, is an architecture that is platform-independent, interoperable, vendor-independent, and today represent also the standard de facto for Industry 4.0. In this slide, I hope you can see it. It's crystal clear that OPCOA enables industrial interoperability across all different levels of the industrial automation space, thus from the sensor at field level to the cloud. And within this context, engineering to foresee this interoperability also across FIWARE-based systems designed and developed the IoT agent. So the agent is an open source component that aims to connect an OPCOA server to a FIWARE-based system through the context broker, leveraging the NGSI and GSI-LD standards. In particular, our idea was to bring the manufacturing data into FIWARE following the RAMI 4.0 specification, where OPC-UA is listed as the one and only recommendation for the communication layer. In the beginning, the agent was intended just to capture data from the OPC-UA server at field to bring them to the upper levels of the FIWARE system. However, today, the agent is mature enough to be able to handling the communication in a bidirectional way through the two levels. Our interest to OPC-UA didn't stop with the development of the agent. In fact, we also started studying and exploring the OPC-UA companions, which we believe play a key role in establishing the industrial interoperability. In particular, the companions express an information model that define the form in which the machines can express certain informations. So to some extent, we can say that the companions translate into a faster integration and configuration of machines into existing production environments. Particularly here, you can see an abstract of some companions among the hundreds that have been released at the OPC Foundation portal. You can have a look at them by following the link put below the slide. However, today we will focus on a specific one, which is the robotics companion. So the robotics companion was born from the joint collaboration of the VDMA and the OPC Foundation Working Group, who aimed to develop an information model for the robotics communication. In this context, robotics stands for a complete motion device system that includes a list of motion devices, and each motion device is an existing robot type or even a future robot type. Today, only part 1 of N has been released, which provides information for asset management and condition monitoring. So part 1 only covers the provision of the asset configuration and some runtime data of the motion device system. For example, the current drawn by the engine and so on. Here you can see the work we conducted at engineering. In particular, starting from the specification, which you can see on the left, we implemented this specification. So we also defined a UML schema for this specification. And moreover, we also developed a fully working OPC-UA server, which is totally compliant to the motion device system specification. Nonetheless, we foresee a potential in the motion device system, especially in the manufacturing domain. For this reason, we decided to bring the specification also to the smart data models. For this reason, the last year we published the related smart data models in NGSI and GSLD standards. Sorry. You can also check the links below if you're interested in this project or in the smart data model. Let's now talk about what's next. So we truly believe in the smart data models as a fundamental key to boost the industry 4.0. And for this reason, we want to contribute even more to the initiative. In particular, we plan to start analyzing new promising OPC-UA companions, but most importantly, analyzing bestsellers machines, which we can already find in some real use cases and pilots. So after that, we want to define the related smart data models after having designed and developed the proper OPC-UA servers. And finally, we want to make the OPC IoT agent able to recognize them. So we plan to start these activities in the following weeks, and we are confident to say that we may be able to bring some interesting results before May 22. There's one more thing. So in many projects we are working on, digital innovation hubs and their services are in the spotlight. And we wanted to standardize them, describing them through the smart data models with a view to establish that integration and that interoperability that we foresee in FIWARE Foundation. So for this reason, we contributed again to the Smart Data Model initiative, and last week we published these two new smart data models. The Digital Innovation Hub, which is a one-stop shop that helps companies to become more competitive with regard to their production processes and their business. And the Digital Innovation Hub service, which is a provision of insight and trends in the market to the companies. So to summarize, the smart data models that I showed you today represents just a starting point for us in engineering to contribute to the smart data models initiative, as we'll be keeping seeking opportunities to contribute even more. And we believe we will be able to present some interesting results before the next summer. So thanks for having joined us. If you have got any question, feel free to ask to the chat below or send us an email. It's the same.
Okay, thank you very much. We have to check the, let's say, the chat where the questions are made. Just let me share back. Yes, we have Ramesh or Rakshit. Please, you can address this question.
Yeah, so Ali, so essentially what is novel about our data models is that it is derived from our ground experiences. And what we see out there is it's literally chaos. It's very uncurated data without a lot of semantic meaning to it. Also, some of the concepts we define are linked data concepts, and we try to define time series data in a way that it is machine interpretable. So that's what is novel about our models.
Okay, I don't know if we have more questions. I cannot see it. Yes, if not, please let me share lastly the screen. So a couple of last questions before you end the session. So this, if you want to get in contact with the Smart Data Models Initiative, you can have here the links. And just to announce that next week we'll have a training. You can see here, and hopefully I'll be able to copy here a training thanks to the I4Trust project, in which you have some training about these data models. Please register if you wish. Is free to join. It will happen next week. Okay, I don't know if there are any other questions to be made from the audience. If not, just let me summarize the session in which we have seen the relevance of the data models as a tools for the actual use of the data spaces. We have seen several examples in which coming from either from the sensor in the space, like the Open Connectivity Foundation was mentioning, or from a very close to the smart cities, or from the IoT devices like the ones coming from the engineering. We know that this data will be possibly interchanged in some data spaces. So in order to do that, we'll have to have some shared data models, allowing us to understand the same as our interlocutors. So therefore, pay attention to these initiatives in which we will be able to provide standardization at market speed, so you can have an issue for not interchanging the right data because you are not sharing the standard. And let me check the questions, and if there are no more questions, I'm not seeing anymore. I want to thank you very much to all of you, and to wait till 1 minute because the next session is ready to join, ready to start. Okay, thank you very much, and see you there.
Thank you, Albert.
Thank you.
Thank you. Bye.
Thanks, bye. I'll go to